Hello and welcome to Hayridge Model Rail. I'm Alan. In this video I'm getting the reed switches and tunnel entrance signal up and working. So let's get started. I've been busy working on the circuit board for the tunnel mouth signal and the fiddle yard reed switches, and I've completed that now and installed it in place underneath the layout. So the next thing to do will be to wire it up. So we've got the inputs, these three just here. You've got ground, positive 5 volts, and the signal connector for the network, and they will be connected up here to this bank. And then we've got the signal connector itself, which is here. So you've got your common and your green and red connectors, and then here you've got a common power and returns to the sensor, which is controlled by this chip, and the two reed switches are down here. So we're going to take some cables from here through here and connect to them, connect up a signal and connect up some power. So what we have here is the code for the network trigger adapter chip, which is an 8-pin pickaxe chip, and it simply reads the network addresses, and when it receives one that the chip is set up to acknowledge, it will send a pulse to the signal chip, telling the circuit or the other chip, the signal chip, that the point has been moved. So the system understands where the point is at any given time, and basically the code lets you set the address for the chip. So within the main part of the program, it just basically repeats until it receives a signal. Well, it actually sits waiting for an address to be given. When it receives it, if the address equals 0, then it will go to the setup program, where you can set the address for the chip so that it can monitor the address that will be sent for the point when the point is changed. And then obviously if the address sent is the same as the address that the circuit and the chip is looking for, it will then come down here to the send section and send a 5-volt pulse through pin C2, the through pin, which is linked to the other chip on the circuit, and we'll have a look at that one in a minute. Obviously, should you go into the setup mode by pressing 0, if you then don't put a matching address in for this circuit and this chip, it puts the board to sleep so that nothing can be adjusted. And it's sort of a fail safe so that you can't accidentally adjust anything. So as network adapters go, this is probably one of the simplest that I've designed, and after a few little issues, mainly with my coding and getting my pins round the wrong way, everything seems to be fine with this. So we'll have a look at the tunnel portal signal. It's a little bit more complicated. Obviously, to make life easier when I'm programming, I create symbols so that I know what certain pins or certain pieces of memory refer to make it easier for me. So it starts reading this, then it comes down to the initialize, so it basically reads the memory, so we know what the last settings were that were stored, and after that it then rewrites the memory default straight away, and then checks to see at what position the point is, and also whether the trigger is high or low, a 1 or a 0, and then it acts accordingly to adjust the signals for you. So should the point be set to 0 or straight, as I believe I've got it set, and there is something sitting in the fiddle yard on that lane, it will then make sure the signal gets set to red. Should the point then change so that it's a 1 and then there's nothing in the second lane of the fiddle yard, it will then turn the signal to green. Should there be something in the fiddle yard, it will keep the signal at red. So simple, relatively simple bit of programming allows me to keep track on what's in and out of the fiddle yard, and will allow the signals to be changed automatically. So come down here, and then all this section does is set the signal to either red or green depending on the information it's received in the set signal section. After all that is done and the signals are set, it goes into this next section, which is detect, and this just loops around until it receives a pulse or an input from either the reed switches, which are under the track, or a signal from the network referring to the point being changed. And then it's a case of adjusting 1s and 0s, whether reed switch 1 has been adjusted or triggered, reed switch 2 has been triggered, or the point has been triggered. And basically the whole program just loops until it receives a signal and then writes the information and then sets the signals accordingly. So as you can see, I've wired the power and network connector in. I'm in the process of taking on color-coded wiring for the layout, so slowly I will be moving everything over so it's all color-coded, and color code for the 5-volt bus and network is obviously blue, yellow and orange, which handily matches the 3-way knuckle connector that I've got. So these packs of cables, I've got 10-meter rolls, have come from a supplier on Amazon. And then out from the bottom for the trigger and the reed switch, we've got grey for the 5-volt supply to the reed switch, and then we've got a white cable that goes back up as the trigger. So they are all connected. I'm now going to connect up the signal, and then hopefully give everything a trial run. So
everything is powered on and programmed. I had a minor problem with a pin out on one of the chips. I got them round the wrong way, and the green LED, which isn't lit up, I've wired round the wrong way, so at the moment I've got a temporary red LED just giving me an indication of what's going on, but that's something I can sort out fairly straightforward. I need to put ferrules onto the new wires, so when I do that I will make the adjustments I need on the board. And as you can see, my temporary signal, which is on the wrong side of the baseboard, is working. I have tested it, but at the moment, as everything's on its side, it's a little bit tricky to run a coach across to trigger the reed switch. So what I've done is just offered up a magnet to make sure that it works. Everything seems to be working fine. So the next thing will be to do a proper test and get that circuit board adjusted so that's all working correctly and the LEDs soldered into place, and then we'll do a proper test. I have drilled the hole and attached the signal to the face of the tunnel, and then I've drilled another 3mm hole, and I'm going to now attach the wires through the baseboard to the circuit board, and then we'll see how it works. I've removed the screws holding the circuit board just so it lets me get the wires for the signal through, because the hole was just by the side of the circuit board. So now I can connect up the LEDs for the signal and then screw the circuit board back on, and then we can see how it looks. So we have the signal installed on the tunnel mouth and hopefully all set up and working. Thanks for watching. Don't forget to like and subscribe, and I'll see you next time.